Hi, in this video we will present and explain in detail our project, a system that helps to take care of our plants. We will start talking about the general architecture in order to understand how all devices and the services work and how they communicate with each other. At the center of all the network there is the Web Garden Catalog. It extends the functionality of Garden Catalog for designing a RESTful and MQTT style catalog. We split the Garden Catalog in different parts: broker, devices, users, and plants. The catalog has two main functions. It registers a new user and a new device through REST architecture. It keeps track of available devices in the network through MQTT subscription. Its IP address is in the configuration file that every device and service can read, so they can reach automatically the IP of the Garden Catalog. Each plant is linked to an Arduino containing a temperature and humidity sensor that sends data every minute, and a servo motor that can open and close a tank. It is possible to connect several plants to our system adding more Arduino. When it registers itself to the Web Garden Catalog, its IP and ID are set by the catalog, while the Raspberry IP and ID are communicated by the Raspberry itself. All the plants are managed by the plant health control that is represented by the Raspberry and has its IP address. It is able to check the status and to irrigate automatically specific plants based on their humidity. Furthermore, it manages the periodical requests from Twitter and the comments received from Telegram. Telegram is the main platform that can be utilized by the user to manage his plants. The Bot Garden IoT bot registers the user at his first access, then allows him to send messages to the plant health control in order to register all his plants that will be associated to his profile, insert and modify all the data about the plant, keep them under control, monitoring their health status and their temperature and humidity, and finally irrigate them. Moreover, the user can check the status of his plants through Twitter. In fact, the system includes also a Twitter bot. Every 6 hours, it retrieves from the plant health control the most recent values of temperature and humidity for each plant registered, evaluates them, and publishes a tweet to make the world know how they feel. The system also includes ThinkSpeak, an open-source Internet of Things application that is utilized to store and plot data from our plants. ThinkSpeak retrieves data thanks to the ThinkSpeak adapter that, as the plant health control, is represented by the Raspberry. ThinkSpeak adapter receives data from the plant health control exploiting MQTT protocol and sends them to ThinkSpeak through the REST method GET. Users can also visualize data in a friendly way through Freeboard. Let's now give a sight to all the hardware components of the system.
We used the PC monitor to visualize the operation executed by Raspberry Pi. Another PC was used to manage the user awareness platforms. Both of them are linked to the plant with a basic irrigation structure. The servo motor moves a lever opening and closing a hole in the tank over the plant to irrigate it. Now we'll try the system and we will show how it works. The first thing to do is to set the IP address of the catalog in the configuration file and also in the IP of the broker in the catalog. Once we have done it, we can run all the programs, starting from the catalog itself. When you turn on the Arduino, it automatically registers itself to the catalog through REST protocol. In this way, your plant is in the database. At the beginning, the catalog sets a unique ID and proper IP for the device. The device and the plant are two different objects linked together by a primary case. As we can see, There are the first device and the first plant, but the plant data are empty until the user fills the fields through Telegram. We developed a Telegram Garden IoT bot that helps the user to manage his plants. At the first access in the bot, it sends a message with a Telegram key that the user has to insert in the catalog database. If you do not write it and you try to check your plants, the bot says that you have no plants. Once we have inserted the Telegram key in the catalog, you can set all the data plants: plant ID, plant name, owner, tweet ID, ThinkSpeak key, and the maximum and minimum volume for humidity and temperature. Now you can get information about your plant: temperature, humidity, and general status. Furthermore, you can irrigate the plant.
This system is very smart. If you forget about your plants, it takes care of them for you. In fact, when the humidity value is too low, it automatically activates the irrigator. The system scalability allows to manage many plants at the same time. We can see an example with 3 plants. Sending a command about the state of the plants, you can see informations about all your plants. Otherwise, with the irrigation command, you can choose a single plant to water through some buttons. The social part of the system is represented by Twitter. Every 6 hours, each plant tweets a message about its status, tagging its owner. Lastly, the user can see the trend of his plants through some platforms on internet. Every time that a device publishes a message with humidity and temperature data, the ThinkSpeak adapter sends them to the ThinkSpeak website through REST protocol. For each plant, there is a channel where the user can see temperature and humidity plot in real time. The user can also visualize the same data in a friendly way through Preboard, that retrieves data from ThinkSpeak. The system supports also many users. This is an example of catalog with many users and plants. If a plant dies and you disconnect its device, the catalog automatically removes both plant and device from the database. In fact, the catalog can see if a device is disconnected because it checks if it has published something in the last 2 minutes. If not, it deletes it.